In today's video, we learn about how to determine whether two functions are linearly dependent or not. To do this, we use the method called the Wronskian. Given the functions y is equal to f of t and y is equal to g of t, the Wronskian of f and g is defined as the determinant of the 2 by 2 matrix where the first column is f and its derivative and the second column is g and its derivative. If the Wronskian is equal to 0, thus if this determinant is equal to 0, then we say that f and g are linearly dependent. And if the Wronskian is not equal to 0, thus if the determinant is not equal to 0, then we say that f and g are linearly independent. With our first question, we are being given f of t is equal to cosine squared of t and g of t is equal to 1 plus cosine of 2t, and we are to determine whether f and g are linearly dependent or linearly independent. To determine whether f and g are linearly independent or not, we use the Wronskian, which is defined as the determinant of the 2 by 2 matrix whose first row is the entries of the functions and whose second row is the entries of the derivative. Let's compute f prime and g prime. To compute f prime, let's rewrite f of t. Cosine squared of t can be rewritten as 1/2 plus cosine of 2t divided by 2. So f prime of t is equal to, when you differentiate 1/2, we are going to get 0, and we are going to use the chain rule to differentiate cosine of 2t on 2. So we are going to have 0 plus, so we can factor 1/2 out. So to use the chain rule, we differentiate the argument here, so which is going to give us 2. Then we differentiate cosine of 2t, which is going to give us minus sine of 2t. Thus we have 2 multiplying minus sine of 2t. Simplifying this gives minus sine of 2t. G prime of t is giving us, when you differentiate 1, you're going to have 0, then plus, you're going to use the chain rule to differentiate this guy also. And so that's going to give us 2 multiplying minus sine of 2t. So this simplifies 2 minus 2 sine of 2t. Now that we have f prime and g prime, let's substitute in these functions into our Wronskian formula. And so we are going to have f, which is 1/2 plus cosine of 2t divided by 2. Then g is giving us 1 plus cosine of 2t. F prime is minus sine 2t, and g prime is minus 2 sine of 2t. Now let's compute this determinant. To compute the determinant, we are going to find the products of this and that. Then we subtract it from the product of these two guys. And so we are going to have the determinant to be equal to the product of 1/2 plus cosine of 2t divided by 2 minus 2 sine of 2t, then minus the product of these two guys. And so you're going to have minus sine of 2t multiplying 1 plus cosine of 2t. Simplifying this, we are going to have minus sine 2t, then minus cosine of 2t multiplying sine of 2t. Here minus will multiply minus, which is going to give us plus. So that's going to give us plus, then sine of 2t plus cosine of 2t sine of 2t. Now let's simplify this. So here we have minus sine of 2t, we have plus sine of 2t, so which will go to 0. Here also we have minus cosine of 2t sine of 2t, and then plus cosine of 2t sine of 2t, so that term also go to 0. So we're going to have our results to be 0. Since the Wronskian of f and g is equal to 0, then we say that f and g are linearly dependent. With our second example, we have f of t to be e exponent t sine of t and g of t to be e exponent t cosine of t. And we are to determine whether f and g are linearly dependent or linearly independent. To compute f prime and g prime, we apply the product rule. The derivative of u times v is equal to uv prime plus v u prime. Thus, you keep u, then you differentiate v, plus you not keep v, then you differentiate u. And so f prime will be giving us, let's keep e of t, then differentiate sine of t, which is going to give us cosine of t, plus you now keep sine of t, then you differentiate e exponent t, which is e exponent t. This can be rewritten as e exponent t cosine of t plus e exponent t sine of t. Let's compute g prime. So here also you have to apply the product rule. So that's going to give us et. When you differentiate cosine of t, you're going to have minus sine of t, then plus. You now keep cosine of t, you differentiate et, which is et. So this is equal to minus et sine of t plus et cosine of t. Substituting these functions into the Wronskian formula, we have the determinant of f, which is giving us et sine of t, then g, which is et cosine of t. F prime is giving us et cosine of t plus, and g prime is minus et sine of t plus et cosine of t. Computing the determinants, we have et sine of t multiplying minus et sine of t plus et cosine of t, then minus the product of these two guys, so which is going to give us et cosine of t multiplying et cosine of t plus et sine of t. Simplifying this, we have minus e to t, then sine squared of t plus e to t sine of t cosine of t minus e to t cosine squared of t minus e to t sine of t cosine of t. Simplifying this, we are going to have, so here this guy is plus, this is minus, so this will go to 0. So that's, we are going to be left with these two guys. So that's, we have minus e to t sine squared of t minus e to t cosine squared of t. Factorizing minus e to t, we are going to have sine squared of t plus cosine squared of t. So this is going to give us minus e to t, and this is not equal to 0. Since the Wronskian of f and g is equal to e minus 2t, which is not equal to 0, then f and g are linearly independent. With our third example, we are given f of t to be equal to t and g of t to be equal to t e exponent t, and you have to determine whether f and g are linearly dependent or not. Let's compute f prime. So f prime is giving us 1 and g prime. So to compute g prime, we use the product rule. So that's going to give us et plus t et. Substituting this into the Wronskian formula, we are going to have t1, then t et, then this side is going to be et plus t et. Now let's compute the determinants. And so we are going to have t multiplying et plus t et minus t et. Simplifying this, we have t et plus t squared et minus t et. So this will simplify to t squared et, and this is not equal to 0. Since the Wronskian of f and g is equal to t squared e exponent t, which is not equal to 0, then f and g are linearly independent. Thank you for watching. See you guys in the next video. Bye.